Oh, my favorite student, good old Ann. So, on your quest tomorrow, you will need to be able to write something in scientific notation. So, number 1, 5.5. Shh, quiet, please. Shh, thank you. Times 10 to the 4th. I'm going to be fussy on this one, all or nothing. Common mistakes, kids count the zeros and they go 5.5 times 10 to the 3. You have to count how many decimal spaces, how many decimal places you've moved it. Number 2, 4.2 times 10 to the negative 1, negative 2, or negative 3? Negative 2. Number 3, 3.64 times 10 to the negative 1, 2, 3, 4, negative 5. Is that correct? Number 4, 1.236. I guess I got to write them all. Times 10 to the 1, 2, 3, 4, 5, 6, 7. Okay. Number 2 says, perform the following. Found your quiz yet, kiddo, or not? I'm going to pause for a second. Number 2, perform the following on your calculator. Correct number of sig figs and in scientific notation. Okay. 2 sig figs. Oh, by the way, just for practice, 1A, how many sig figs is 55,000? 2. How many sig figs is 0.042? 2. How many sig figs is C? 3. How many sig figs is D? 4. The 1, the 2, the 3, and the 6. Scientific notation is the easiest because when you write a number in scientific notation, technically you're always only just writing the sig figs anyways. So if you have a number in scientific notation, that's way easier. Oh, we got a latecomer. Pause for a second. So 2A, 2 sig figs, 2 sig figs. I'm going to go to 2 sig figs. So I'm going to type in my calculator. 7.1, scientific notation, negative 4, times 3.6, scientific notation button, negative 7. I guess the second sig fig is the 5. Is that 5 going to stay a 5 or become a 6? How do you know? Because the number next to it is 5 or bigger. So 2.6 times 10 to the negative 10. All or nothing. I'm going to be fussy. Okay. All or nothing. I'm going to be fussy. You can always do corrections, but I want it to sting a little bit so that you won't make the mistake. Can you mask up now, kiddo? Excuse me. Pardon me. 3 sig figs. 2 sig figs. I'm going to go to 2 sig figs. 1.42 scientific notation, negative 5, divided by 4.3 scientific notation, negative 15. Oh, 2 sig figs. The second sig fig is that 3 right there. Is that 3 going to stay a 3 or become a 4? Because there's a 0. So 3.3 times 10 to the... Yeah? 9? Yeah? 9? Yeah. Works better in my Block F class because I actually have a German exchange student. So anyways, 3.3 times 10 to the 9th. Number 3 is tricky because it's scientific notation, sig figs, and adding. And the adding rule is always a bit trickier. If you give me a number in scientific notation and you say add it to the correct number of sig figs, I turn it into something I already know how to do. I write it in standard form first. 0.0060. That's what 6.0 times 10 to the negative 3 would be. 0.00035. Then I would say to myself, 4 decimal places, 5 decimal places. I'm going to go to 4 decimal places. So on my calculator, I'll go 0.0060 plus 0.00035. How many decimal places? 4. I'm going to round to that 3. Is that 3 going to stay a 3 or become a 4? It's going to become a 4. So it's going to end up becoming 0.0064. And now when I write that in scientific notation, 6.4 times 10 to the negative 3. That's a lot of work for one question. I get it. And again, I'm going to be fussy because you can do corrections all or nothing. Now we get to the unit conversion. Hey, what's the first thing that I always do when I have to convert something? I write down what they gave me. 3.0 seconds. Now I'm going to multiply by a conversion factor. I want to get rid of seconds. Where's seconds going to go? On the milliseconds on the top. Double check, is it 10 to the negative 3? Yeah. Where does the milli go? Where the where does the 10 to the negative 3 go? Where the milli isn't, which in this case is on the bottom. So it's going to be 3 divided by 10 to the negative 3. Is it 3,000 even? Is that right? Okay. You could also have written that in scientific notation. I didn't bother. It would be 3 times 10 to the third. Is that okay, Diego? Good. B is a 2-step question. I'm going to get rid of kilo. Then I'm going to bring in milli. I'm going to write down what they gave me. 25 kilograms. Get rid of kilo on the bottom and just plain old grams. Kilo is 10 to the third, and the 10 to the third goes where the kilo isn't. If I stopped there, that would be grams, but now I want to get rid of grams, bring in milligrams. Milli is 10 to the negative 3, and it goes where the milli isn't. So it's going to be 25 times 10 to the third divided by 10 to the negative 3. And I think when I do that, I'm going to write this in scientific notation because it's less work. If you wrote a 25 followed by 6 zeros, full marks. But I'm going to write it as 2.5 times 10 to the 7th milligrams because that's less writing. C, also a 2-step question. I'm going to get rid of the giga and then bring in the micro. It's going to be 3240 gigagrams. I'm going to get rid of gigagrams and just plain old grams. Is giga 10 to the 9th? I'm going from memory.
Yes.
Yeah. If I stopped there, I would be in just plain old grams. But now I want to get rid of grams and bring in micrograms. And micro, I know, is 10 to the negative 6th. So it's going to be 3240. This is going to be big. Times, you're probably going to get an answer in scientific notation. Am I right? I think. Yeah, 3.24 times 10 to the 18th. Micrograms. I will be fussy on the test for the unit conversions. If you don't write the units next to your final answer, I'll take a half off and tell you to go work for Verizon. Question.
When I put that on my calculator, instead of 18, I got 50.
So you made a typo. I'll look at yours later and I'll try and figure out where it was. It almost guarantee was a typo. Okay. 4.6 decades. Okay. 4.6. My abbreviation for decades, I just decided to go DEC. I don't know. First, I want to get rid of decades and turn that into years. I know that 10 years is 1 decade. Now, you might have skipped that. You might have just said, look, I know 4.6 decades is 46 years. If you did that, Alex, in your head, fine with that. But walking you through the whole procedure. Okay. I can turn years into days. Now, we at one point actually had, in the lesson, remembered how many seconds there were in a year. I haven't memorized that. If you have, use it. Go ahead. I couldn't remember it, so I said, I know it's 365 days is 1 year, and I know that it's 24 hours is 1 day, and then I said it's 3,600 seconds in 1 hour, and I said, okay, I'm good to go. It's going to be 4.6 times 10 times 365 times 24 times 3600. And I got, I'm going to write the whole thing out, because to write this in scientific notation properly, I would technically have to write the 1, the 4, the 5, the 0, the 6, the 5, the 6. Then it's less work just to add the 3 zeros than it is to do the times 10 to the. If you round it off, 1.5 times 10 to the 1, 2, 3, 9th, or 1.45 times 10 to the 9th, I'll give you full credit because this is a big number, but I'll write out the full answer. 1450656. 1450656. 3 zeros, and that is seconds. Sheesh. Okay. 46 years is about 1.5 billion seconds. Gotcha. E. Ooh. This is a 2-level fraction, and I'm going to write it that way. I'm going to write it as 325 kilometers on the top, nanoseconds on the bottom. Sadie, I'm going to do 2 things. I'm going to change kilometers to centimeters, and I'm going to change nanoseconds to teraseconds. I'm going to do them separately. I'll do kilometers to centimeters first. That's going to be a 2-step. Get rid of kilometers, bring in centimeters. So step 1, get rid of kilometers, goes on the bottom. Plain old meters, and 10 to the 3rd goes where the kilo isn't. Now, get rid of meters, bring in centimeters, 10 to the negative 2 goes where the centi isn't. This is going to be a big number, I can already tell. If I stopped there, I'd be centimeters per nanosecond, but Sarah Ashley, I want to end up in teraseconds. Sarah Ashley, where's nanoseconds in the original fraction? On the, so it's going to go on the, in my next one. And just plain old seconds, and nano is -9, I think. And then, if I stop there, no, I want to keep going. Seconds on the top, teraseconds on the bottom. Tera 10 to the 12th? Jeez, this is going to be big. 325 times 10 to the 3 times 10 to the 12th. That's everything on top. Divided by 10 to the negative 2. Divided by 10 to the negative 9. Do you get 3.25 times 10 to the 28th? People nodding? Okay. And that is centimeters per terasecond. All right. There's going to be a section on your quest where I just ask you to do some operations with sig figs, and I don't care whether you write them in scientific notation or not. We're multiplying 3 sig figs. Ooh, 2 sig figs, not 1. I'm going to go to 2 sig figs. 1.25 times 0.50. The second sig fig is that 2. Is that 2 going to stay a 2 or become a 3? Going to become a 3. Final answer, all or nothing, 6.3. 3 sig figs. Ooh, 4 sig figs. I'm going to go to 3 sig figs. 51.3 times 3.940. The third sig fig is the second 2 right there. Is that 2 going to stay a 2 or become a 3? It's going to stay a 2. I guess the answer here is 202. Am I wrong? For the first one? For which one? 6.3? Oh, you know what? I did times 5 instead of times 0.5. Let's try that again, Mr. Dewick. So 0.63. Is that right? Still got to go to 2 sig figs, though. Sorry about that. Thank you for catching me. You caught it, so you get a candy. 3 sig figs, 4 sig figs. I'm going to go to 3 sig figs. 4.37, scientific notation 3, divided by 0.008560. I guess the third sig fig is the 0. Is that 0 going to stay a 0 or become a 1?
1.
Now, what some kids do is they go, oh, the answer is 511. But no. Look where that 0 is. It's the third column over. So we have to add the zeros there, which is why that's to 3 sig figs. Yeah.
Are you going to be thinking about that on the test?
Yes. The answer is 511,000, not 511. You're off by over 500,000, by 500,000. I'll be very fussy. Now, adding and subtracting, the rule, Riley, is completely different. It's not how many sig figs, it's how many decimal places. 3 decimal places, 5 decimal places. I'm going to round to 3 decimal places. 68.002 plus 0.12378. The third decimal place is this 5. It's going to become a 6, 38.126. Okay. I don't know why you would do that. That'd be silly. 2 decimal places, 1 decimal place. I'm going to round to 1 decimal place. 512.06 minus 65.2. 1 decimal place, that 8's going to become a 9. 446.9. Ooh, number 6. There will be a long chain for you to try and deal with on the test. So here's what I noticed. Write down what they gave me. And what they gave me is 48 parrots. Then I said, well, I can get rid of parrots because apparently 5 parrots are 1 zebra. Then I said, hey, I can get rid of zebras because apparently 1 zebra is 8 monkeys. Then I said, okay, I can get rid of monkeys because apparently 6 monkeys are worth 1 gorilla. Then I said, I can get rid of gorillas because apparently 5 gorillas are worth 2 lions. This will work. I end up in lions. So it's going to be 48 times 8 times 2 divided by 5 divided by 6 divided by 5. And I think you get 5.12 lions. Is that correct? Yeah. If you got that, I will give you 3 out of 3. Now, if you didn't get that, I would give you 1 mark if you wrote down what they gave you, because that's what I've taught you as the first approach. I would give you a 2nd mark if you tried to build a chain. Even if your chain was wrong, if you tried doing it using my method, I would say, good, I want to reward you for that. The 3rd mark would be for getting the correct answer. If you didn't put units next to your final answer, if you didn't put lions or an L, I would take a half off because that's how I roll. Okay. Number 7, John estimates the height of a lamppost to be 8 meters. The actual height is 7.6. Calculate the absolute error. So you can either go 7.6 minus 8, or you can go 8 minus 7.6, but it's the positive answer. So I usually just go bigger minus smaller. Absolute error is 0.4 meters. And then the percentage error is going to be 0.4 divided by the correct answer, 7.6. And then times 100 to change it into a percentage. And I get 5.263. I would take 5.3. I usually go for percentages to 2 decimal places, so I'm going to go 5.26%. Can you give yourself a score, please, out of 22?